Okay, this video, it talks again with creating equations. This is 1.2.2, but we're focusing on inequalities. And again, I have another video based on showing you what inequalities are. So inequalities, again, is a range of answers. Like for instance, if you have to have at least $100 to go on a trip somewhere, it's okay to have $110 or $120? Yes. So it's a range of answers where it has limits, okay, opposed to a finite, like single answer, okay? So all these equations are inequalities, and they're going to have inequality symbols in it instead of equal signs. So let's kind of talk about three examples here to explain that. Juan has no more than $50 to spend in a mall. So he has the most $50. So is it okay if he only spends $49, 48? Sure. But he can't spend over 50, because that's all he has. He wants to buy a pair of jeans and some juice. If the sales tax on the jeans is 4% and the juice with tax costs $2, what's the maximum price of jeans one can afford? Okay, so let's kind of highlight a couple elements here that are key. Okay, so the juice is $2, jeans tax is 4%, and is at most 50 bucks. Okay, so let's first define what our variable is. So I'm going to call J for, and this is the price of jeans. Okay, and that's kind of what we're shooting for. Now let's think about this. The inequality says we have at most $50. So you can spend all $50 or less than. So it has to be less than $50. And the two things he wants to buy are jeans and juice. Okay. Now the jeans composes of really two pieces. The price of the jeans plus the tax of those jeans, and then we still have the juice. Okay, so here's kind of like the different pieces that we have to worry about. Okay, so let's kind of build an equation here. So it says here, how much are the jeans? Well, the jeans are just the price of J, whatever they are. The tax is 4%. Now again, it's 4% of something. Of what? The price of the jeans, and jeans only. So that's why the J goes there. Then the juice has the tax included. So this is a flat price of $2. And all this has to be accomplished spending less than or equal to $50. So notice here is my equation that I'm working with. Okay, so now what we want to do is simplify it. Notice these two items are like terms. They both have to do with the price of jeans. So 1 jean plus 0.04 jeans is 1.04 jeans. Okay, and we still have this. Now, a lot of people are saying, well, I can do this in my head logically. Well, we want to support with the algebra and show you how logic and algebra are the same thing. First thing logically says, well, let's pay for the juice. Let's get that out of the way. So we subtract the 2, and we have 1.04J is less than or equal to 48. Okay, now it says, okay, we have to divide this out. So we're going to divide out 1.04, do the opposite of multiplication. And now we have J, I'm kind of running out of room here, it's less than or equal to, and this comes out to 46.16. Now again, I'm rounding to 2 cents because the calculator says actually 0.153. Okay, but we have to be at least under 16 cents here. Okay, so that is the maximum price we can spend for jeans because you have to allow for the tax and the juice. Okay, so good first kind of warm-up problem to kind of look at that example. Now this one says Alexis is saving to buy a laptop that costs $1,100. So that's a key element. That's her total. So far, she has saved $400, and she makes $12 an hour babysitting. So that's good. And notice we don't have to worry about tax in this scenario. What's the least number of hours she needs to work? So again, if she needs to save $1,100, is it okay to make $1,200? Sure. Then she has some more money left over. So here the inequality is going to be she has to make more than or equal to $1,100. It's okay to make more in this case. And what we want to do is we have the savings plus how much work she has to put in order to meet her goal. So what are the savings? The savings $400. That's a constant. Notice it doesn't change. She has $400. And then what's work? Well, work is number of hours she has to work. And again, and that's hours of babysitting. Okay, so hours of babysitting. So she makes $12 an hour for the number of hours she works. There's a term. 12 is your coefficient, H is your variable. Those are two factors. Together, multiplied, produces how much money she's going to make working. And it has to be bigger than this, okay? All right, so there's our equation. There's our statement that's an equality, okay? So what we have to do first is, well, let's take off the 400 that we have already saved. So by working, she only has to save $700. So now when we divide by it, we figured out, all right, we need to save at least 58.33 repeating. Okay, so 58 and a third. So roughly, you're going to say, oh, I need to work, 58 and a half or 59. Okay, so you're not going to work like just like 20 minutes and leave. You're going to work at least an hour, depending on how you get paid. You get paid every hour, every half hour, whatever the case is. So, you know, I would, estimate that, at least 58.5 to cover yourself. And that seems more logical based on the context of the problem. I'm talking about babysitting here. Okay, so that's a good example of how to set that up. Now this one here, whoops, the next one is actually just in the bottom part here, so let's just scroll down. Okay, so this one is a little bit more complex. So it says the radio stations give away concert tickets. There are 40 tickets to start. They give away one pair. So again, I'm just gonna make a little note. That's 2 tickets. Okay. Every hour for a number of hours until they have at most 4 tickets. So you can have at most 4. So it's okay to have 1, 2, 3, or 4 tickets, or I guess 0 if you want. Um, but the most can be 4. Okay. So right now the number has to be less than or equal to 4. So they've kind of established the inequality portion. The contest runs from 11 a.m. to 1 p.m. So that's the total of each day. Kind of reading this here. So it goes from 11 to 12 and 12 to 1. So that's 2 hours each day. Okay, so 2 hours a day. Because the question is, how many days will the contest last? Okay, most we're going to be probably working in hours, but we have to at the end convert it to a day. Okay, so let's see here. We start with a constant of 40 tickets. Then from there we give away, so we subtract 2 tickets for every hour. So here I'm defining the variable as the number of hours that we're on air. Okay. So here we have the equation. Okay, so notice we have a constant, we have another term that's made up of 2 factors, a coefficient and a variable, and then a constant over here. So the first thing we're going to do is move the 40 to the other side. So we have negative 36. And to get rid of this negative 2, we're going to divide by negative 2. Now, when you divide by a negative, which I learned from inequalities, is that you have to switch the sign. So really you have to work, have at least 18 hours of this contest in order to have 4 or less tickets. Okay. So now this is in hours. So if there's 18 hours, and we want to figure out how many days it's going to take, we have to convert. We've established there's 2 hours for every 1 day of the radio show. So it's not like how many hours are on a day. We're talking about how many hours they're on air. So if you do this, 18 divided by 2 is going to equal 9 days. Okay. So notice we have to change the units to that. Okay. Well, we have to be able to logically go through and set up each piece and understand where they come from. So when we're looking at this, we're like, this is the total. Kind of looking back at it, total minus what we give away, and it has to be less than or equal for the grand prize. Okay, so those are kind of the different pieces. Okay, so this is a good video to watch for 1.2.2, I believe.